Hello and welcome to AgriTalk, a show about all things farming and what you can do to make your farming operation better. And this may be one in, I don't know if you want to say a series of shows talking about soil, or what some people might call dirt. But there's scientists like our guest over here make a big distinction between dirt and soil.
Oh, absolutely, and in some cases mud, as it is today. It's quite raining quite well, but I always say that dirt is, we farm on dirt, but most of our researchers and the gentleman we have with us today is he'll debate that, and it's soil,
Right.
and he says dirt is on the floor, so
Right.
that's where we'll leave the dirt on the floor. So today we have Yogi Raut, or Yogendra Raut. He's from the Ohio State University South Centers. Good day, Yogi. How are you?
Good, good. So far, everything is good.
Good, good. I'm glad you could be with us. Could you tell us a little bit about yourself, Yogi, and your position and what do you do there at the center, and maybe how long you've been there?
You did turn on your mic, right?
Yeah. I have been working with Ohio State University for, this will be my 14th year.
14 years.
3 years I spent in Columbus, Cotman Hall, or Columbus campus. But then after I moved to South Center, Piketon over here, and as a research associate. And my current work is, I'm involved in most of the research that we have currently, and most of the lab setup with all the equipments that I use. And I have also additional responsibility at this time, I can say, but I'm finishing up my PhD work. With whatever research I started. So one of my research, I'm using that research as my PhD dissertation. Maybe I will touch upon that also briefly about the result.
Sure.
And then I have a couple of research over here related to soil and water and the bioenergy that we can discuss a little bit all in brief. Mostly results part.
Okay, great.
So what brought you to Ohio State? Why did you choose that?
I was working back in Nepal with U.S. government also, and then situation came there politically that we have to decide that, we had to decide that whether we can continue. I was working with seven countries across that region from Nepal, and then in Nepal had some turmoil politically. Then when we are working with American people, then we had a difficulty to get the security from the government, U.S. government there. So it was kind of that kind of situation. So I decided, okay, let us move by that connection. I happened to move to Ohio State. The only reason was when I came here, then I applied mostly in my field. By then it was kind of hard to get any job in my field. Then I switched a little bit differently. So all of a sudden, one faculty from Ohio State, he did his postdoctoral training in Australia, where I graduated from the same university. And he came up with, okay, I need your expertise on this soil. And I happened to join with them. That's the connection, one thing. I really applied several places, several faculty, which I thought maybe is close to my expertise. So he the one who responded because of maybe that reason that he came up with the same university from Australia. I graduated from Australia. My master I did from Australia, New South Wales.
So was this field what you wanted to do in the first place, or did you originally come for one particular reason and end up in this
That's a good question. Actually, I was basically trained for animal science, that is veterinary science, before I was working that. But when I came here, I had to come up with the kind of licensing. So it was hard for me in the first time. Then second option I had left because I graduated from Australia with grassland science, which is forest science, also you can say rangeland science. So I was in one of the international research institute. I was working in Nepal that works for China, India, Bangladesh, Pakistan, Sri Lanka, those other countries, and then others, 2-3 countries combined. So altogether 8 countries. I was working in China also from there, and I was working at the same time India and some of the location in Pakistan. But the center is in Kathmandu, Nepal. That is the center that was established by UNICEF. So I had kind of like I was working as a rangeland research scientist over there. So that expertise I use here, which is very close, I got in soil. That's the story. I ended up working with soil. So now I can say I forgot about all animal science or those veterinary science subject, but I can say a lot about soil science and this bioenergy or those kind of things. I can discuss a lot in terms of environmental science, because I'm working with my PhD. I'm almost I have defense maybe next 2 weeks. I have to come up with my defense, and that research is related to environmental science program, graduate research in environmental science. And I'm using one of our burning issue here for conservation reserve program land. That is my hypothesis, and my claim is like we started this in 1985 in US, but we haven't done anything more. We haven't harvested any biomass from them, so we are losing everything. But if we harvest, we somehow, then we will be gaining something. So that was kind of issue I saw when I came here in 2009. I was watching TV news in White House. They had a discussion that how we can. It's almost right now. It's almost 28,000 million acre, 28 million acre all over the United States, and that is a big resource that we have to trap, which is right now is completely ignored in terms of when we see we have to come up with bioenergy, renewable sort of energy, then that is the biggest part we are ignoring, we are trying to overlook. So I want to, there is a research that we conducted here that I want to make and bring it into the picture, that how and what result we are getting from there. We will talk about a little bit the result, particular result, what we got.
Okay.
So,
Well, let's start off with Yogi with tillage. I know you've done some research on tillage and no tillage. Tell us a little bit about that. And is this for big farmers? Is this little farmers? Is it your garden? You know, that kind of thing. Let's start there, and let's talk about some tillage as we begin into this, and then we'll get into some fertilizer options and things like that.
of course, this is a very good experiment that we have been working on for long term, because those are the things that when you are talking about the sustainability kind of things, then my impression is when you talk sustainability, then you have to come up with the longer term scenario instead of getting like a couple of years research and then you are talking about the sustainability. My impression is you have to give enough time to rectify yourself that data will be talking about the sustainability. For keeping in that mind, we started this long-term tillage experiment in maybe 2007. Yeah, 2007. So we had a couple of, lot of information, and then we compared basically in this case, you can use no tillage versus tillage. You can use both scenario, and then also you can use chemical fertilizer, which tri-state recommends for corn and soybean rotation. Then you can use cover crop as a means of fertilizer. So basically what we compared, one set of information we had all the chemical fertilizer you use and you till. The another set of information we had, you don't till at all and you use no fertilizer at all. Then instead of fertilizer, you are using different cover crops combination to come up with whatever nitrogen need, especially nitrogen need, the plant will have. And after 5 years of that experiment, we found and we compared both fertilizer use setup and tillage setup and the cover crop with no tillage, no till, will give you the same amount of yield, same yield, which is like 150 bushel per acre, is the same in both the scenario, and plus you will get better soil quality in the cover crop when you use different combination of cover crop and no till than versus what you can say in tillage system with all the fertilizer. So it was exciting information side by side we were getting, and then you will see no weeds in the cover crop area, but some weeds even you can see in the fertilizer use area. So that was a very interesting information that we got after 5 years. We have continued that experiment. Now we can see after that so many years, maybe I think it's 11th year right now we are getting from that experiment. Now they are even yield in terms of corn yield, we are getting even higher in cover crop treatment than fertilizer. So that we haven't come up with how much, but then we can see plant are even better, greener in cover crop area than the fertilizer use and continuously tillage side. So it's kind of very interesting that we got this kind of information, and plus soil quality. If you take the soil quality, it's a very difficult subject how you can interpret the soil quality, but we have some parameter that we use how to compute the soil quality, and we are getting very exciting results from both the scenario.
Now, how would you pick a cover crop? I mean, could I just let weeds take over and say, that's my cover crop?
Well, maybe we should ask, some people may not know what a cover crop is.
Right.
So give us, what do you consider a cover crop, Yogi, and when is that applied? Obviously, you don't put it on when you plant, but after you harvest, right? And then how long does that cover crop stay on there?
Cover crop is a very interesting question you ask me right now. Cover crop is, we are trying not to do separately. So cover crop is the time frame when your land is basically fallow. When you don't do that, anything, that's the time you have. You
So
don't have any
that's basically through the winter, right?
Yeah.
So
Winter and before winter, that when you harvest corn or when you harvest soybean, you don't have anything in that time frame.
right. So that's when you plant it.
That okay.
So it's not a complementary thing at the same time that the corn's in.
Right.
It's not the same time, it's the time that the corn's not there that you put the cover crop on.
Yeah, when you don't have main crop, then you use cover crop. And basically in Ohio, we don't have to use any chemical fertilizer to kill the cover crop. So we use as a winter, like a temperature by itself, that you are saving a lot of energy, a lot of resources, rather than using any chemical, any kind of pesticide or any kind of chemical to kill those plants, to get the energy out of it. But here we have advantage that after onset of winter, those plants that we select right now is getting automatically killed by the winter.
So what
And
what kind
this-
of plants are those?
We use alfalfa, also we use coffee, they call black IP, is the most that is coming like a very good in this condition. Then we use winter peas also, and then after we use radishes. This is I'm talking about the leguminous crop, which has a lot of nitrogen, but versus non-leguminous crop, but they have other advantage also. Then we use rice cereal to use as a cover crop, and those are the plants that you select based on the experience that you can grow better in this case. So we have here two things separate. We can grow, it's just the Columbus and Piketon, we saw the difference. In Columbus, you can grow winter peas very well, but they cannot grow cowpea, which is black eyed pea, very well. Here we have opposite. We can grow black eyed pea, which is also called cowpea, very well, but we don't get very well establishment with winter peas. So it's kind of little bit difference in the geographic or some soil type with and moisture and those kind of things. But cover crop like coffee is very good even in water stress condition. You can grow very well.
And the cover crop is what you're considering fertilizer, right? Or it applies fertilizer?
No fertilizer. That's why we are also calling cover crop as like a homegrown nitrogen. That's all organic.
Yes.
Because it's
don't
when the
any-
roots and the plant breaks down in the springtime, right? It's kind of rotting
Yeah.
in the soil and breaking down.
When they get killed by winter, maybe some other cover crop we want to keep during winter as well. But I'm talking about just right now that some of the cover crop that you choose will be killed by winter. And once they get killed, then bacteria works on them and they try to break down them, they try to decompose them, and then you will get all the released energy or all the released like a nutrition that will be used by your subsequent crop, either for corn, either by corn or soybean, based on what rotation you have in your area and in your case.
Okay. Do we want to switch subjects now? We've got
Yeah.
about 10 minutes.
Yeah, we're running quickly out of time, Yogi. Tell us a little bit about the next topic of coal waste, and just briefly, what is that?
Yeah, we have here, because the bioenergy topic that is recently coming is a lot of debates that how you can grow them efficiently and less, where you don't have to spend a lot of resources. So it was coming like how you can grow. So we have some different types of bioenergy feedstock plant, like miscanthus we use, but miscanthus grow very well. It's a introduced species, exotic species, which we want to use for bioenergy feedstocks, and it has a very high yield capacity, but also it needs a lot of nutrient. So we wanted to feed that nutrients through two sources. One was from municipal waste, that is a burden to the city. And another one, we wanted to use waste, which is coming from coal power plant. They call FGD, flue gas desulfurization, which is a scrubbing material that they use to reduce the sulfur dioxide. When they burn coal, they emit sulfur dioxide. And Ohio coal has a lot of sulfur, so they don't want to emit the sulfur. So you scrub them with the water. They have different system, and with all this, then you will get basically flue gas desulfurization, which is nothing. Is kind of like a lime material. They call calcium sulfate,
Yeah.
which you can use to your land to get the other fertilizer, instead of other fertilizer, you can use them. So we were using both in the combination in one of our experiment that was miscanthus, and we found calcium sulfate, which is FGD, you can say, also they call gypsum. They are not very helpful in anything like you can raise your pH. Normally, if you have acidic soil, people had mindset that it will, because of the calcium sulfate, it is calcium based material, it will raise the pH. It doesn't do that, but it helps in other nutrition. Same way we use like a municipal waste, sometimes we call sludge. That was our burden to the city. We use as a fertilizer, and you have a tremendous amount of nutrition from there. So in both the combination, we saw miscanthus, you can grow up to 25 ton per hectare, which is almost the same per acre, which is very high. And you can grow miscanthus for bioenergy feedstock with less amount of resources, and at the same time you will be alleviating the load for the environment also. So both ways we found the FGD and then biosolid from municipal waste work very well to come up with a very good yield from the miscanthus.
Tell us a little bit more about miscanthus, Yogi, and what is it? A lot of people we're just saying it's a grass, but excuse me, it's something that grows really quickly, right?
Yeah, it's very quick. Growth is very quick, but miscanthus is like, before we had two different variety. First of all, we came with the variety that was asexual propagation. Asexual propagation that you don't have seed, but you can separate like a saplings or plant itself, and then you use that plant into your, in your area or in your plot. Then the farmers came up with the concern that it cost a lot, because you have to buy separate cuttings or maybe some plants from somewhere else, which is cost for transportation, which is cost for by itself, like somebody has to grow it. Then they come up with either any way, possibility we can grow this plant by seed. So there are two options we were using. We came up with seed as well, which was one of the company, they developed that variety, both sexual propagation and the asexual propagation, which is by seed. And both are tremendously working fine here. So far we have 5 years. Then farmers came with the concern that if it is, because since this is not our native plant and they don't have a lot of experience with this plant, so they had a kind of question or concern that since we are getting this from outside, that it will be going wild, since we have a lot of experience that this exotic species, sometimes you get like a weed wild, sometimes even in the animals, like in fish, we are getting some kind of like exotic species getting wild. So if they get the same thing, same problem here. But we found in both the condition, like asexual propagation of miscanthus and the sexual propagation, which is seed, both cases, we don't find anything that is going to be wild. So and it's a very cheap source of cellulosic material. It has a very hardy kind of stem that you can get harvested when they are not green. and you will get a lot of biomass as a cellulosic material. So if you are using any feedstock material for bioenergy purpose, then it's a very common recommendation that you don't want to harvest when they are green. Because when you harvest as a green, you are taking a lot of soil nutrient from the soil, which will cost you in longer that your system will be getting depleted with all the nutrients. When you are harvesting dry, which is kind of like once they get mature and winter, then most of the nutrition they get set back to the soil system back, and then you are harvesting whatever you are harvesting as a dry, that's mostly biomass as a dry, or maybe cellulose you are harvesting. Most of the nutrient is getting recycled back to the soil, so system is getting more sustainable in that case.
So with just everything that we've talked about, tillage or no tillage, obviously it doesn't matter a whole lot because you're getting the same yield. So no tillage would give you better because you don't have all the extra fuel running across the fields, things like
Sure.
that. So that's a plus.
Do you need a different thing to
Excuse me.
plant, a different seed drill or whatever that?
A little bit, nothing too drastic though. No major change on that. And then obviously the fertilizer option about putting cover crop on or not, and that's obviously we do want to put a cover crop on. Now that's when you say cover crop, is that something that you would plant on your garden as well?
Yeah, you can do that also in a smaller area. That's the same. Application will be the same.
Okay.
But one thing I didn't mention earlier, that when you don't have anything during fallow time, no living plant over there, then most of the time we have issue. Some of the excess fertilizer, like either fertilizer or maybe some other nutrition, they get leached out from the soil and getting into the stream water system.
Yeah.
So when you have something growing all the time, it is getting recycled and they use that. So they prevent, especially you can say mostly nitrate. Nitrate is a problem all the time.
So it tends to hold it there in the soil.
Yeah.
So
Both nitrate and phosphate, they are negatively charged nutrients that plant takes. And when you don't have plant, they have nothing to hold. So they get leached out and getting out of the system and deposited or accumulated in the water system. So then water system you have problem. Otherwise, and in other way, you are also getting depleted. When you need, you won't get this. So when you use cover crop, they hold when they are live, and by the time when they get killed and released, next time you have subsequent crop already there. So it's kind of helping in the recycling process also.
sounds like a good place to stop and a good place to start off to another session.
It sounds like
next
we
time.
could do another show with Yogi here.
Absolutely.
Yeah, we can do another show for other bioenergy experiment that we have. We have a very big setup of bioenergy, anything, related to bioenergy in our university system. So far, it's a big display over here.
Cool.
Okay.
Okay.
Well,
thank you for being with us, and thank you, the viewers, for taking the time out of your day and watching. And hopefully you gained some good information out of this. So we'll see you next month on AgriTalk.
Thanks, sir.